Every year we make 450 million tons of plastic, and this is set to quadruple by 2050. It's hard to conceptualize how big of a number that is, but fundamentally this is destroying our environment, this is ruining our health. Plastics are a fundamental part of modern life. They enable life-saving surgeries to happen, they reduce food spoilage and waste. We shouldn't get rid of plastics, but we need to fundamentally find more sustainable ways to deal with this material. Today, only 2% of plastic is truly recycled. With every loop through the current recycling system, plastic loses its material properties. It's simply cheaper and easier to use virgin plastic. We've developed a new kind of solution for plastic waste, biorecycling. We're designing programmable enzymes that can transform plastic wastes into different chemicals. This technology can dramatically reduce the carbon emissions coming from today's chemical industry, all whilst cleaning up plastic waste. I grew up in London. I went to an international school and I studied everything from biology to environmental science to Mandarin. Growing up, I was watching a lot of David Attenborough documentaries. I was then able, when I was 16, to go travel to Mexico and participate in a number of beach cleanups, and what should have been a very pristine environment was absolutely littered with plastic waste. It was a huge eye-opener for me. Everything was so clear. I asked myself, what if we could turn all of this waste into something of value? I was working on this research project during my final year of school, but very quickly realized that I didn't have a PhD and needed somebody to help me take that forward. So I got in touch with Doug, who's this world leader of systems and synthetic biology. We hit it off very quickly and decided to start the business together. What we've developed are enzymes that are capable of breaking the highly stable bonds that make plastic so persistent in the environment in a matter of hours. This is not something that's been done. So in order to produce our enzymes, we program microbes by giving them the genetic information on how to make the enzyme, and then we train them to produce it at a mass scale similar to how we ferment beer. We then take all of that information and we feed that data into predictive modeling to make predictions as to which enzyme variants we should design, build, and test and learn from next. We repeat that cycle until we have an enzyme that has the performance requirements that we want. The biggest challenge in deploying our innovation is making sure that what we do at the lab scale effectively translates to what we want to do at an industrial scale. And so we have to do a lot of smart experimentation, planning, process designs in order to effectively manage that scale-up process. Transforming manufacturing from an extractive exercise into a restorative one is the very definition of sustainability. If we're going to continue to live on this planet the way we want to, we need to find new ways to make things. What we want to achieve is a profitable system for recycling plastics. That creates more incentive to collect, sort, and process this material. That means less of it will end up in the natural environment and eventually on our dinner plates. So what we're building is not just a solution for plastic waste, but is also a way to decarbonize chemicals manufacture. One of our mid-sized facilities at scale has the potential to offset 500,000 tons of CO2 equivalent per year, which is equal to taking 100,000 cars off the road. At an industrial scale, we'll be able to take waste plastics from post-manufacture, post-industrial, and post-consumer sources. Once the enzymes break down the plastic, what we're left with is a soup of chemicals which can then be purified and sold to make lubricants, fertilizers, all sorts of different things. What our technology allows is the ability to profitably and at scale remediate plastic waste. That means in the short term we can create more sustainable ways to manage the material that we're producing, and in the long term we can set our sights to cleaning up the 10 billion tons of plastics which are just sitting around taking up space. Our innovation will enable consumers to not feel guilty about using plastics for all the amazing properties they have. They'll be able to buy products off the shelves that are made using renewable circular chemicals made from plastic. This is the first time in human history that we know the destructive impact we're having, and we have the tools at our disposal to reverse it. Our hope at Epoch is that we can use the most advanced technology on the planet, nature, biology, to solve our most intractable environmental challenges. I'm Jacob Nathan, and I'm the co-founder and CEO of Epoch Biodesign.